do. We're recording now. This is our last lecture and guided practice. And I'll catch you in just a sec, Anna. And so here we go. We're going to get ready to do this. So Anna, do you have a question?
Yes, sir. Actually, I have three questions.
Okay.
When I do my for the creating the dynamic blocks, always I don't know why I have an extra block or extra line. Actually, I tried for 2 days, but I couldn't make it. I don't know why I couldn't make this cabinet. And one of the other questions that I have, if I want to choose again interior design, I have to go to the second part, right?
If you want
And
to do what?
if I want to do again the interior design for
Oh
the
yeah,
week
you can.
six.
So you can either just continue with more of what you're doing, or you can try the dynamic blocks and things like that. It's really very open.
Okay.
I have to put something down for people, but it's really do work that will help you get better.
Okay,
How's
so
that?
if yeah, it's really great. I don't complain. Just I want to know that if I want to create the complete the dynamic blocks, then I want to be sure that in each slide just in the portfolio or in the week six assignment, I have to use each cabinet and show it in the each slide or
No, so and actually I'll show you how some people have done that
uh-huh.
and been able to show sort of all the blocks and one at a time. So for the portfolio, you just need to demonstrate enough examples to show that you've got that skill. So you could show, so even if you made 10 of them, because that's what's useful, you could show it with just one.
Okay.
But I'm going to go ahead and somewhere in here, I'm going to come into here. I think it was in the advanced tools that I actually saw this. So here's an example of one. This is how one person showed it, where they kind of had their little drawing in the background, right? And then they had the little block definition thing up, and they just put a bunch of these over on the side to show. So that's a pretty, this is just showing one of them right here, but you can see, oh, well, maybe that's one, they're all these little different ones that this person chose to make, and they were able to show it all on one slide. Does that help out? Is that sort of like what you were talking about?
Yes, sir.
Okay, and then here's another one where the person showed what they had made, and then they showed all the little blocks that they had over here. So that's another neat way of being able to show it. So those are two ways that I saw that people were able to show doing the blocks. And just to let you know, some of these slides are from last spring that you're going to see in here, and some of them are from now, because I use the sort of the same stuff over and over again, and then people present them in different ways. So I think this one was from done in the spring, but I really liked it. So I put it in with this stuff. And then oh,
Actually, I do it the same as this one exactly.
like this one or the last one?
No, this one, the
Yeah,
last one. I mean the last one, the
like
last
that.
one. Yeah,
Like
exactly the same as this one.
yeah, no, that looks really good. Well, maybe It's amazing. You had another great idea just like that, or maybe this one might have been yours, and the other one was the one from last week. And then this was another cool one. So these were things that people had done. So just so you know, this work is more than, why isn't this going I guess I have to close this. Hold on a sec. This work that you see here, this is more than what's required in this course. If you did like anything on this, you're at the advanced end of this course. This is not normally considered part of the introduction to CAD. I like to do it because I think people can do it and it's interesting and it's fun and you can do more. So
Okay.
so if you did anything like this, you're really doing good work. You're
Oh,
really doing good work.
thank you. And I have another question.
Okay.
For a video, just I have to upload. I have to upload again in the same one of the slides.
Yes. That's what we'd like you to do. Yes.
Oh, okay. And
Cool.
I have to just, I mean, take a video when I do the creating the dynamic block and use them in the, for example, the plate 8. Yes.
Yes. Yes.
Okay.
That's
Thank you.
exactly it. Yep.
Okay. Thank you so much. I
O-
appreciate it. Thank you, sir.
Okay. Well, cool. That's what we're all about, trying to get all these things squared away. So let's go through, and this should help sort of figure things out for ways that you can maybe work with your portfolio. So yesterday's lecture, I just clipped stuff and kind of had my AutoCAD up and running. Another way to do it though is to use sort of the slides that you already have, and you're welcome to do that. So these are basic skill sets. This is sort of slide, the first two slides, or the first slide that says what are your basic AutoCAD skills. So look, you sort of already, this is somebody's, you've sort of already got that. You've got workspace setup, you have drawing lines, you have, here's another good example of that. And these were from that executive summary. So rather than going back to your AutoCAD and taking snip, 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 you might go back and just look at your executive summaries and see how those look. Isn't that nice? These are really nice. And this could literally be that AutoCAD basics slide, maybe with this added in or something like this. Here's a nice one because it's calling out editing commands, orthographic projection. If you look back here, that one went with, I think this one, maybe it went with this one. Workspace setup, line and shape practice, and then editing commands, orthographic projection. And those four things sort of take up most of that first AutoCAD basics. And so these are just nice presentations that I saw. This is another nice one. These are all and this one includes some of the dimensioning and layering and things like that. So here, this is this one, it's just nice to see how people have laid things out. It's just so cool. I love seeing all the wide variety of students' work, and everybody is doing great in this one. Oh, and here's another one that adds some layering, some text, some dimensions, some measurements, some assembly. So this is another nice. So you might have a couple of pages, but these all came out of those, you'll recognize that from your executive summary. So the executive summary was sort of there to help you figure out ahead of time how to do your portfolio. Aren't these nice? These are just like really, really good work. These are really cool. Okay, so that's just a little bit about how you might do those. And I just went into people's weekly portfolios and snipped out visualizations of work. Now, in the next part, for complete drawings, could have done the same thing, but then I decided to go back in and get these. So these are just people's work. They're very nice, and you can identify what they are. Mechanical complete drawing, architectural elevation, architectural perspective, mechanical orthographic, mechanical orthographic. This is a cool one. Isn't that neat? So I gave people the opportunity to do a construction project in Minecraft. And it starts out with a site review, and then walking and grubbing the site, marking the site, grubbing the site, doing backfill and compaction, and then layering down your substrate, pouring your pad and building your foundation, and then building to a plan. So this if you'll look at this is very similar to the building that we've done. And then of course you get to do your own sort of architecture. Isn't that cool? And this is CAD, by the way. It's computer aided drafting and design, but in reverse. You're reading the CAD drawings and doing construction according to construction systems. So I flippin' love this. And everybody who does it just makes the coolest looking stuff. And this is Minecraft educational. If you're a Minecraft fan, you'll know that if you're in the Java version, they have what are called shaders. And I've seen shader packs that you could not tell the difference between this and a photorealistic rendering with some of the shading packs that people have for it. Architectural shading packs. There's a guy who sells them. He has a Patreon account. He's got 6,000 followers or patrons on it that pay $10 a month. He makes $60,000 a month by selling shading packs, architectural shading packs for Minecraft. Wow, that is really cool. But anyway, so there was some neat stuff about that one. Here's more. It's mechanical. Here's another mechanical. And now, Stephen, I don't know if you had a chance to go back and do that one as 3D and do that cutout, but that's why this one is so ideal. Or if you got a chance to look at my 3D tooltip one, where this is essentially just a couple of extrusions, 1, 2, 3 extrusions, and then view this as a half section. It's like, wow, it's so much nicer in Inventor.
That's an interesting one to draw.
What's that?
It was an interesting one to draw.
This one?
Yeah, I did. I did a lot of guessing on that one.
Did you do it as a 3D model?
Not yet.
Okay, maybe I'll do that when we're done here. I'll do this one as a 3D model, and I'll show you how fast it goes. Yeah, so all this stuff down here gets a little kooky, right? Because you have to project across, and where is it really projecting across, and Do you need to show this? Do you show this? Do you show this? Do you show this? This does get goofy down here. But you're going to see that when you do it as a 3D model, oh my gosh, it's so much easier.
Oh yeah, because what I did was I took the top projection, copied it over to the right quadrant, rotated it, and then I just intersected all my lines.
Right, right. Which is essentially the quick way to do it. And then you just had to figure out what is where, right? Is this hidden? Is it visible? What's this one? You know, that's what comes up with those ones. You know, like having to cut that little piece out right there, right? And cut that little piece out to remember to do that.
Yeah.
So kind of neat. Electronic schematic again, some floor plans. So these are just things that again I just pulled out of people's portfolios just to show good work. You know, these are just nice. I love seeing good work. And when you see it over and over again, that's really cool. And so I think I got something of everything except for the landscape one in there. And then more, this we just looked at just a minute ago. These are some of those ones with blocks. Of course, I don't have a ton on this one because, you know, I'll call the advanced tools were the express tools, the super hatch and the special line types and things. And there wasn't a ton of work done on that, just some. And so, and maybe I'll get more at the end of this week. But that's good stuff. And these are neat, right? That you can make your own kind of block letters and put your own hatches in there that look like super cool, interesting things. So that's just some of the good work that's been done so far. I always do this at the end of the semester. I grab cool work and I go over it and do neat stuff. So let's go ahead just for fun, just because I want to show you how to do that. And Stephen, you want me to do that one in AutoCAD or do you want it in Inventor? The drive lug. Which one works best?
Inventor, I think, would be good to see.
Okay. So I'm going to call up really quickly that file. That was in completed drawings. Right. There it is. And I'm just going to bring it down here out of the way so that it's not being seen. Okay, so here we go. So to do this in Inventor, maybe I will bring it up. So there's Inventor. Inventor is just for this type of mechanical work, it's AutoCAD on steroids. AutoCAD used to have all of these capabilities, but when they bought Inventor and made it a standalone product, they basically stripped a lot of it out of AutoCAD, which I can see why. AutoCAD is supposed to be now a backbone tool, not the specific tool for every use. And so we'll draw this drive lug in Inventor. So what we do is we model it, and then we go ahead and make the drawing. And I'll bring this down in size a little bit. And I'll make it a part, right? That's when this comes up. This is just going to be a standalone part. Fine. There it is. Now I've got, whoops, maybe not going to work. That is not going to work. All right, so I'll have it. I'll just display it down here and look at it and just let you know what I'm doing. A little bit bigger now. So this thing is essentially a big cylinder with some pieces cut out of it. So I'm going to start it as a sketch, and I'll sketch it in this plane. And it's a cylinder, which is what's my out 6-inch diameter, and its overall height is 4 inches. So I'll extrude that 4. So that's it. And then there's a hole in it. And the reason I'm going to make it a hole is it's got a very special tolerance. I'm not going to worry about the tolerance right now, but I can go right there to that end and I can put a point on it. I could also draw this thing, but I like to do it this way. And then I'm going to say that there's a hole there, and the hole has a diameter of 3.52. And I can look at all the tolerances on it and everything later on. So I just did my front view. So now I'm going to call, I should have gone the other way so that my front view matches up. But that's okay. I'm going to call this my front. And I see that there's a 2-inch wide the wrong one there, rectangle. It just has to be bigger. So it's 2 by any amount, but I could snap it down onto there so that I make sure that I get everything. And then what's so cool is now I'll extrude, not that part. Oh, you know what I need to do? Let me go back into there. And now I'm going to just make 2 areas to extrude. This has to be at least that big. So now I've got 3 segments, and I can extrude that one and that one, but I can go back the other way. And does it tell me how far to go back? 1 inch. Got it. And I think, oh, let's see. I did that backwards. I was doing it right before. That's the back side. The front side, this piece goes back. Sorry, I'm not reading my drawing very well. So there's my front piece. And then on the back side, I can do the same thing, and it's lined up in the same direction. And I can make this any width that I want, right? Doesn't doesn't have to match up. Just has to get past the end of it because I'm going to take it away. I could do anything. And now on this one,
I just drawing another rectangle to give it another surface. Is that all that's doing?
yeah. there's my part, right? And then there's got to be some hole through it. So check this out. I know that my hole is on that plane. And it's 1.97 back. And I'll put a point right there. Well, actually, this one, what is that hole? Just a 0.8 diameter hole. So I'll make a 0.8 diameter hole there. And then that will extrude the other direction. And I'm going to cut it out and I'll go through all. There we go. There we go. So I got it. I think I've got it. There it is. So there's my part, right? So that was pretty quick. Save as drive lug.
Aren't there a couple extra holes?
Are there extra holes? There's just that one hole.
I thought there was some going the other way. I don't have the drawing up.
Yeah, no, I think that's the only one. And I might have gone the wrong direction. I might have to move things around, but I think I just have that one hole. Okay, so now I'm gonna go ahead and make this thing. So I'll come up to the top, right click, whoops, and create a drawing view. Now, the sheets as they come in are huge. The default is a D size sheet. So once it's in there, I got to double click and right click, edit sheet, and make it a B size. Probably even an A size would be fine. And then I'll make this is also a pretty large one right here. So I usually get rid of that one. The template is kind of set up kind of clunky. That's a better template. So now let me get my base view. And it looks like I need that as my base view. I think maybe it's that one. I think that's it. Yep. And now I can project my view. Now here's the cool thing. I want to make a section view over here. So I think there is my section view. And if I wanted to show, now section views in general do not show hidden lines because the purpose is to show the section. But they've showed hidden lines here, so I'll go ahead and do that. Right click, click, where's my edit the view? Edit the view and change it to hidden line. And there it is. So really and truly, you wouldn't normally do that. And then if you want this line to go away, you can turn its visibility off. So
now, don't you also need the 3D?
Yep. So now to get the 3D one, I'll project this one. think. Let's see. There it goes. There's my 3D view. Isn't that cool? That was really neato. Kind of, kind of, kind of neat. And then of course, there's all sorts of things to do. This doesn't need to be there. But you can't erase it. But what you can do is erase the text. You can't get rid of it, but you can erase the text if you want to. And then there might be some moving around of stuff. You might have to move that up just a little bit to get some things to fit nicely on here.
And then we still dimension it.
Yep. And so when you do your dimensions, that's just under annotate. And it's dimension. Now, it can be kind of goofy here. So I see that there's a center line. And I'll do the center line between I'm not sure. There we go. That's how I do that center line. And here's my center mark. And this, I can right click and not show the entire line. And I can take that visibility, oops. So there we go. So I might have to actually draw a full center mark because it's extension line, punch centers. It says it'll do it. But I think because it's made out of, it's not a full circle, it's not putting the full center line in. There we go.
Would it be easier then to put the center line on the inside circle and then just extend it?
Oh, yeah. Yeah. Well, no, because see, they're all pieces parts too.
Oh.
So. Hi, Donald. Doggy came in to say hi. Hi, Donald, you boy. Good dog. Do you need to go outside? Or are you just hanging out? Hanging out here. That's my 12-year-old little doggy. And then when you do some of these dimensions, you know, and that's really a goofy way to set that up there, but that's where they did it.
Why is the hole on the hidden lines up there on that top view offset?
Well, it's interesting. When you go in and look at it, see, they're not out there. So it's this weird, when you do your hidden line, it's kind of a funny thing. And so, see what it is? That hole really does create that.
Okay.
Mostly, we wouldn't show that in our drawings, but when we were just doing it by hand, we'd draw the line. But this is truly a projection of it. And same with over here, right? We know that when a circle intersects a circle, it's not a straight line, it's a curve. Okay. Now, if you need, now this one is 3.52 plus or minus. So here we go. And I have to right click. Let's see. It can be hard to, once I've got it down here, I have to right click and tell it I want it to be a diameter. And then I can put my precision and tolerance over here. And that's symmetric. It's actually symmetric 0.001. and my primary unit is going to be 3, and my tolerance. So see how you have to kind of play around with it when you have one that's non-standard. But that's how you get that one on there. All the other ones, I think, now, I don't know what that thing that says 0.001 tolerance means. That doesn't mean anything. You have 0.001 tolerance written on it. I'm not sure what that one was referring to, unless that was the RMS.
It was on the drawing or on the original, just like that.
Yeah, I don't know what that means.
I didn't either. I couldn't figure out what their chart was for.
It doesn't mean anything. So you can leave that off. That absolutely means nothing. But you could put, I think what they were doing is saying that there needs to be a surface. Right? So surface A, B, C, maybe a 32. Let's see where that ends up. There we go. That's a more, that's sort of how those are done. I don't know what those tolerance things were. Now I think I can add liters to this. Well, that didn't work very well. Add vertex leader. There it is. So if you click on it, you can add leaders. Isn't that nice? I mean, if anything is on there, that's where they would be.
Now, what was your tolerance that you put in there, that 32?
32 surface finish is there any ridge or extension above like a perfectly flat plane is no more than 32 3200 microns, 32 microns. So usually people will have like a little machining key, a little thing that has those surface finishes that you can look at and see and feel. Like a 32 is pretty good. That's a very, very good milled surface or a very, very good lathe surface. 125 is sort of like you're just sort of running it over to get a dimension. A 250 would be a roughing cut. And root mean square, it's just it's a mathematical model that they use when they're doing laser type inspections. So
Okay, yeah, the annotations that were on the original drawing from the catalog, I couldn't find anything to interpret them.
yeah. Yeah, well, it's an old drawing, so I don't know. And that's usually what I do is, I go over it and then I go, okay, this is goofy. Let's not worry about that. Let's worry about something else. But this is a basic class. If you get something like this done, it's kind of cool. But look, that was, 20 minutes and you've got the actual part and you've got that. So it's pretty neato. Now you would think, this kind of weird because this should actually be smaller than this. In general, right? The drive key is smaller than the drive slot. But that's not listed on here at all anywhere. It's just a really dumb. It's not dimensioned properly in any fashion at all off of the thing. But don't worry about it. You're just copying what somebody, I'm sure an architect drew this and this was their mechanical thing and they didn't know what they were doing. When I teach my machine design class, I go into this one. It's a really cool little part. And it's good to talk about. But for now, you just need to be able to know how to put something on it. Cool? Here's another one. I think I put this on as a whole. So you could, instead of having to do this, you could put this on it, and then you get to do, like, that says through, but if it went to a certain depth and all this kind of stuff you could do. And this is where you can talk about threads. If you have a thread on it, here's your precision and tolerance. So maybe what you want to do is show, well, I didn't put it on the hole, but you could call this hole out as like a standard tolerance, a loose fit, a force fit, a sliding fit, a shrink fit. And there's all these tolerances in these books that you could call them out as. So all sorts of different ways that you can do it. Kind of fun. Cool?
Yeah, it was good.
And now I have to figure out, how do I get rid of this? That's how. Okay. So that was a little bit of Inventor, and of course I'll save that. So I save a drawing file, and I save the part file. And then I've got, it's like, it's quick. Inventor really, really is. Now, you could do all of that in AutoCAD too. This is a simple enough part, but making that section view is a little bit harder. You can do it, but it's just a little bit harder in AutoCAD. Okay. Any other questions or comments as we finish up? Yes, Anna.
Sorry, just I have a question about again the interior design.
Uh-huh.
In the part two, just you mentioned the using one of the two files provide. These two files. You mean the 9 plates? Just we use in the week 4 and week 5.
Let me go
or...
look. I might have been thinking about giving you a file to use. And not done it. Let me go look. I better check that out. That's interior design. Wow, I was supposed to. Don't worry about that. Don't worry about. Yeah, that's I was going to give you one to work with, and but you're better, you just go ahead and do this one. I was going to go get one of the ones that I had from last semester and let people do some realistic Photoshop renderings and drawings. but I forgot. So,
Okay.
so you can just keep working with this one.
Actually, I didn't know how to add the attribute to the cabinetry blocks.
Okay, let me show you how to do that because
Thank
that's
you.
a neat thing to be able to do. And it doesn't take too long. It'll take just a minute to start up. And it's a great skill. And like I said, we used to teach these as part of a class called Design 405, which was how to really do cool stuff with AutoCAD. But AutoCAD has gotten easier and easier and easier. So now we just sort of lump it in places. So you're doing, in reality, advanced work when you're doing this. So congratulations. You're doing really good work. Um, Here we go. I have to do a little bit of setup like you guys always have to do. Get this to look right. That's the one drawback to working with VMware, but I try to do it like students need to do it so that I'm aware of, what some of the things that take time are. Okay, so I'm just going to make a block. And it's going to be kind of a clunky looking little cabinet. And my cabinet's going to really be weird. Just to give it something to there's my cabinet. Now, I might want to say something about this cabinet when I put it into my drawing. I might want to say who's the manufacturer, what the size is, things like that. So I'm going to do something called make an attribute, which just lets me type stuff in about it each time. So I'll make the tag of it as the manufacturer. And for now, we'll just use the same tag. And whoa, that didn't work. And my default, I'm going to write as Home Cheapo, not the same as Home Depot. And I'm going to make it really small because I won't really need to see it. And I'm going to make it invisible. So it doesn't show up in my drawing, but my data is there. And I'm going to put it way down here in the little corner. So every time I put the block in, it's going to ask me about that. And then I might do another one about the size of this thing. And so this thing is going to be, I'll just go width by height. So I'm going to put those two things in, and let me put the material in just for fun. And I'm going to say it's made out of particle board. Okay. So they're just tiny little things, and it's an attribute definition. Now I'm going to make a block out of this. So that's the only difference. Now I'm going to make my block. Create my block, and this is going to be my cheapo cabinet, ATT, dynamic. Attributes and dynamic. And I'll use my midpoint, and I'll select my objects. And I have to select more objects. I select these in the order I want them to show up. I get everything? No, I need that. And then remember, I want to open it in the block editor. And so isn't that cool? This comes up every time I put the block in. I'll call this one 10 wide by 18 tall. I don't know. And now I can do those cool things that I did before. There's my distance 1. There's my distance 2. Here's my actions, which I said was going to be a stretch. Number 1, going in this direction. And I'll catch all of that stuff. Select objects. Oh, select the objects. And so I got that one done, and then I'll do my stretch distance 2, going that way. And the objects will be all of those. So let's see if I even came close to doing it right. Well, I stretched the wrong way probably, but that's okay. Yeah, I did my stretch in the wrong direction, but I can still make it work. So now look, here's what's going to happen when I insert cheapo cabinet. Let me make it 12 wide by 18 tall. Now I'll make it 12 wide by 18 tall. And there we go. And I don't see, I've got it, and that information is in there, but I don't have to see it. But when I extract it, I'll be able to pull that out as you've seen before. So this will be my cheapo cabinet data. I'll select, I'll just get that stuff for now. Of course, I could get everything. And I want stuff about my block. And what do I want to know? I want to know about the dynamic block. I want to know my distance 1, my distance 2, and my material manufacturing and size. And so that's what's going to come out when I do it. Isn't that neat?
Thank you.
And if you know how to do that, you're like a prized possession when you go to look for work. Because, you know, if you can set up your drawings, and even if you just understand how to use this, this is how interior designers can very quickly get all of their information about this. It's really, really cool. And you might wonder why this size is different than these distances. And that's because this is what's called a nominal size. And sometimes the actual distance is a little bit different. Okay, so that's why that's that way. Is that cool? I love this stuff.
Thank you.
Okay. And like I said, anything you get done is advanced compared to, look what you've done in 6 weeks. I just think you students are amazing.